Hello, this video is the first part of a series of 4 videos where I explain a technique of integration called trigonometric substitution. This technique involves substituting the variable of integration, which is usually x here, by a trigonometric function. I'm going to start with the first case of trigonometric substitution, which is an integral containing the square root of x squared plus a certain number. Now here, we will be solving the integral of x cubed over the square root of x squared plus 4. So what we do is that we substitute the variable x by 2 tangent theta. First of all, why it's 2? Because 4, it's 2 squared. So we substitute by 2 tangent theta because we have x squared here. So it's going to be 4 tangent squared. And then we can take 4 into factor and put it outside the square root. And in a bit, we are going to see why we use tangent. Now with theta being between minus pi by 2, pi by 2. Now, surely theta can be in r minus, excluding the values plus or minus pi by 2, because this is the domain of tangent. But we choose this interval because tangent is increasing, strictly increasing in this interval, and it has an inverse. But I'm not going to go into details about this choice because it's not the goal of this video. So x is 2 tangent theta, which means dx over d theta would be 2 secant squared theta, which means dx it's 2 secant squared theta d theta. And the square root of x squared plus 4 would be the square root of 4 tangent squared plus 4, because x it's 2 tangent theta, which means we get 4 tangent squared theta plus 4. We take 4 into factor, and then we put it outside the square root. It's going to be 2. So now we have 2 square root of tangent squared theta plus 1. And tangent squared theta plus 1 is secant squared theta, because secant squared minus tangent squared is equal to 1. So we get 2 square root of secant squared, which is the absolute value of secant. But since theta is between minus pi by 2, pi by 2, secant is positive in this interval, which means the absolute value of secant theta is secant theta. So now we got rid of the square root here by making radical x squared plus 4 to be 2 secant theta. And now what we do is that we replace in our integral. So we replace x by 2 tangent theta, square root of x squared plus 4 by 2 secant theta. And don't forget dx, we replace it by 2 secant squared theta d theta. So I becomes 2 tangent theta cube over 2 secant. This is x cubed, this is the square root, and this is dx, 2 secant squared theta d theta. So here we get 2 cubed, it's 8. We simplify the 2's here, we simplify the squared and secant. So we get 8 tangent cube theta d theta. Now, if it was secant squared, we would have the form integral of u prime u to the power n, because the derivative of tangent is secant squared. And the integral of u prime un would be un plus 1 over n plus 1. I have a video explaining this technique that you can watch if you want, but we are not in this case. So what we do is that we replace tangent by sine over cosine. So tangent cube is sine cube over cosine cube, and secant is 1 over cosine, which means our integral becomes 8 integral sine cube cosine to the power minus 4. Now here, the power of cosine is even, and it's negative also. The power of sine is odd. So what we do is we take sine cube, we write it as sine squared multiplied by sine. Sine squared is 1 minus cosine squared multiplied by sine, so we get sine theta minus sine theta cosine squared theta. I have many videos explaining how we integrate product of powers of sine and cosine depending on their power, if they were even or odd. You can watch them if you like. So now we replace sine cube by sine theta minus sine theta cosine squared, factor of cosine to the power minus 4 here. We expand, we get now integral of sine theta cosine to the power minus 4 minus sine theta cosine to the power minus 2 theta d theta. Now we have the form, if we add a minus sign here, or if we multiply by minus 1, we get the form u prime u to the power n, where n is minus 4. But if we multiply by a negative sign here, we need to put a negative sign outside the integral also. So when we integrate, we will get minus 1 over minus 3, because n plus 1, it's minus 4 plus 1 minus 3 cosine to the power minus 3. Also here we will get a plus because we added or we multiplied by minus 1, so it's plus cosine theta to the power minus 1 over minus 1 plus a constant c. Now cosine to a negative power, this means it's 1 over cosine cube, so it's secant cube, and this one is 1 over cosine, which is secant. So we get 8 over 3 secant cube theta minus 8 secant theta plus a constant c. Now we have to go back to our initial variable of integration, which was x. Always when you make a substitution in an integral, you have to go back to your initial variable. So here we have to go back to our initial variable x. We look at the substitution that we have done. X is 2 tangent. What we have also, we have that radical of x squared plus 4, it's 2 secant theta, which means secant theta, it's the square root of x squared plus 4 over 2. And this is the one that we are going to use. So we replace in our final answer secant theta by square root of x squared plus 4 over 2. And here we can simplify. We have it cube here, so we can simplify 2 cube and 8. This one and this one, because 2 cube is equal to 8. And here we can simplify 2 and 8, we will get 4. So our final answer would be 1/3 square root of x squared plus 4 cube minus 4 multiplied by square root of x squared plus 4 plus a constant c. Thank you for watching, and don't forget to subscribe to our channel.